Great. All right. Welcome to another SETI Live. I'm here with another FDL team. My name is Sarah Jennings, and I'm the executive producer for FDL in the US. Frontier Development Lab is an applied artificial intelligence research accelerator, and we are bringing together the brightest minds from around the world in space science and exploration domains, and we're pairing them with machine learning researchers to tackle problems in the areas of heliophysics, astronaut health, lunar exploration, and earth science. This is our 5th year that we're doing FDL, and it's hosted by the SETI Institute and in partnership with NASA. And we are obviously here taking it virtually. We have 8 teams this year at FDL. These teams right now are in week 5, which is our improvement week. And this week I have with me the lightning team, lightning extreme weather team. So very excited to have them and for taking time from their busy schedule to be able to join us today. So thank you. We're going to kick it off with some introductions. And so I'd like if each of our researchers from this team to share where you are from and what you are currently working on. So we'll start with Marek.
Thanks, Sarah. My name is Marek Slipski. I'm currently a NASA postdoctoral fellow at the Jet Propulsion Laboratory in Pasadena, California. And my research focuses on the climate of Mars. So I've studied sort of how Mars's atmosphere has evolved over billions of years and processes that are going on today.
Great, thanks, Marek. Glad to have you. And I'll turn it over to Maria.
Thanks, Sarah. My name is Maria Molina. I'm currently an advanced study program postdoctoral fellow at the National Center for Atmospheric Research, and I work on better understanding how severe storms, which produce hazards such as tornadoes and large hail, how these storms are changing and will be changing in our future climate. And I use tools like high resolution modeling, so physical models, and also machine learning to answer some fundamental questions on these storms. Thanks.
Great, thank you. And Iván?
Hello, my name is Iván Venzor. I am from Mexico. I live here in Mexico. I work in a bank. I lead a data science team. In bank, I have a PhD and 2 kind of masters, and I'm very happy to be here. I also teach. My local kind of university is the kind of Universidad Autónoma de Nuevo León. So yeah, very happy to be here. Thank you.
Great, great to have you. And we have Nadia.
Hi, I'm Nadia. I'm actually a professor in computer science at 3 different institutions. I also do research with the UC Irvine Machine Learning Nexus with the School of Physical Sciences, and I'm excited to be here.
Great, thank you, Nadia. All right, so we're going to go ahead and dive in now. So to kick us off, Marek, I would really like if you could share a little bit about the challenge and what it is that you're working on.
Sure. So the title of the challenge is Lightning and Severe Weather, Lightning and Extreme Weather. So our focus here is specifically like tornado and hail, these severe weather events that can cause a lot of destruction. So the storms that lead to these events are associated with lightning. And so our focus is to use observations from the geostationary lightning mapper, which is an instrument on the GOES satellite, which looks at the Western Hemisphere and sees about 1 million lightning flashes per day. So we're working to use that lightning data to see if we can predict these severe weather events, to give more lead time, to help forecasters issue warnings for these events, and to see if there's any undiscovered sort of science in this data set that hasn't really been explored in great detail.
Great, thanks, Marek. And I just want to take a second to welcome our viewers. We have viewers from Chile, Norway, India, Morocco, Prague. So thank you for joining us. And Maria, you and I both live in Colorado, and I think we've both experienced probably some of these extreme weather events that you're working on. Can you talk about why this challenge matters in the work that you're doing?
Yeah, so we're focusing on tornadoes and hail, and these hazards pose a threat to human life and also economic damages. And so if we can increase the lead time, we could potentially increase the time that people have to seek shelter and just better inform the public on these hazards. Another aspect of our study that is helpful is that the geostationary lightning mapper was recently launched just a few years ago. And so we have this source of data, lightning data, that we can learn to use and help improve these weather forecasts for the public. And then I guess more broadly, this matters because hopefully we can use machine learning to make some new discoveries on the relationships between lightning and also severe hazards.
Great, thank you, Maria. And we're in week 5, so you guys are a little bit halfway through the FDL program itself. So I would like to know a little bit more about the tools and processes that your team is currently using to address the problem. So for that, I'll turn it over to Iván.
Thank you. So for this kind of challenge, we are blessed that we have been sponsored by kind of Google Cloud Computing. So we have many GPUs and instances servers that we could use to kind of process data. So we have to process kind of several millions of files to get into our working models. So as for the techniques that we are using, we have been trying several of those techniques. We are trying to use some graph neural networks because Flash can be seen as a kind of graph. So you have Flash extensity, you have distances, and then so you can model those as kind of graphs. So we are also using CNNs, but with the temp time. So we are using some kinds of LSTMs plus CNN networks to be able to predict where's the next kind of severe weather event will be held. And we are also using some non-supervised techniques because we are also kind of trying to learn these jump team and these lightning jump kind of signatures. So we want to also be able to recognize when this kind of signature happens. So there are some unsupervised techniques that we are trying. So one good side of our kind of challenge is that we are able to apply a lot of techniques, and we are in the middle of the process to choose the kind of one that feels the best for this kind of problem. And once more, we are very happy that we have this kind of Google Cloud platform, because we have a lot of the resources that we need. So thank you.
Great, that's wonderful. And because you guys are in week 5 now, you guys are getting deep enough into it that you might be experiencing some roadblocks. So Nadia, what is your team currently working on those things that might be causing your team some interesting conversations and difficulties?
So we've had a lot of challenges just dealing with the data set. Because you're dealing with satellite imagery is multispectral. The images are extremely large. And depending on the kind of sensor you're looking at, whether it's the advanced baseline imager or the geostationary lightning mapper, they may differ in terms of the temporal scale. In addition to that, we have parallax just from the field of view of the satellite compared to triangulating that to a location on Earth. So just getting the data set prepared was most of the challenge for this team. Now, moving into week 5, our challenge is what sort of approaches could we utilize to best tackle this problem within the given amount of time for this challenge. So there's different scopes that Iván mentioned earlier, different techniques that we could utilize, different sources of data, external sources of data. What kinds of external data are going to be the most meaningful for us in terms of prediction for severe and extreme weather?
Great. Thank you so much, Nadia. And thank you again to our viewers that are coming from Poland, France, Hawaii, Scotland, Montreal. And also in a few moments, we're going to open it up for audience questions. So if you're thinking about any questions that you'd like to ask this team, please share them with us and we'll get to ask a couple of questions. So Maria, at the end of this 8 weeks and even beyond, what are you guys hoping to achieve?
Yeah, so our ultimate goal is to help forecasters so that they can help society and the public in providing accurate forecasts to increase trust in our weather forecasts. But I guess specifically, we want to maybe provide our model for some testing within a test bed. So every year there's an annual workshop that is held in Norman, Oklahoma at the National Severe Storms Laboratory. This is called the Hazardous Weather Test Bed. And so we hope that we can share our work with them and they can provide us some feedback on our model and whether our model is used and continued in a research to operations pipeline or inspires some of these researchers to improve their own work. That would be a great achievement, I think.
Great, thank you, Maria. And while we're waiting for the questions from our audience to roll in, I'll go ahead and kick one off for each of you guys. For your experience with FDL, what is one thing that has surprised you or one thing that's been really valuable to you throughout this FDL experience so far? So I'll go ahead and start with Nadia.
So I think relating with our mentors, learning from them, learning new tools just in an extremely short amount of time has been amazing. And then just meeting incredible people. We just spoke to an astronaut minutes ago and I'm still trying to recover from that talk. It was really amazing.
Thank you, Nadia. Yeah, that was great getting everybody back after having just talked with an astronaut. Marek, how about you?
Sure. Yeah, I'll say that like this is obviously just our team for this challenge and seeing all the other challenges around and just realizing how many people are able to use sort of different tools and just trying to latch on and pick up what you can for each of those and try to fit it in to make our workflow better and give us better results has been really exciting.
Wonderful. And Iván?
Yes, thank you. I could talk a lot about methods on, for example, techniques and kind of so on, but I think that the most important thing of FDL is the people, right? This is a kind of community, so you are working with people like you that wants to work in something meaningful for the NASA, for SETI. I mean, we try to do something that is meaningful. In our case, we are trying to help these forecasters to do a better job to kind of protect us, right? So in the end, we are really, all of us are kind of trying to do something meaningful, and all of us, I think what I like the most of FDL is the people, this kind of community. I am very happy to be here.
Great, thank you. And Maria?
I fully agree with Iván. I think being a member of this community and just the resources that everyone brings to this community, their experiences, their fields of expertise, and coming together from so many different areas of expertise and bringing that knowledge together in this multidisciplinary way is a really special experience that I will always treasure, and I'm glad to be a member of FDL.
Great, thank you, Maria. All right, it looks like we have a couple of questions from the audience. So our first question is, do weather forecasters currently use algorithms for forecasting? Can anyone speak to kind of what the state of the art right now is?
Sure, I can take this. So forecasters are certainly using the outputs of a lot of algorithms. They're looking at all sorts of different data. So this is radar data, this is satellite data, and they have a lot of experience in using that data to make forecasts. So there's certainly a lot of calculations going on behind the scene, but the forecasts aren't generated by a single equation that then gives you a probability of something happening. They're trying to take their knowledge base and use the data to give a reliable forecast.
Great, thank you, Marek. And yeah, I know we had a conversation yesterday about just how many different data sets that these forecasters are using and that it varies. So really interesting work. We had another question from the audience of what's the most surprising thing that you've learned about lightning? And I think this would actually be really interesting to hear from either Iván or Nadia about what you've learned about lightning in your short period of FDL.
I've learned that I don't understand lightning yet. There's so much to learn about lightning. Just the kind of mechanics of it and how particles hit grapple and that somehow creates electric charge, and ice crystals are going up in the cloud and it's hitting things like billiard balls and creating charge, and that gets discharged somehow magically. I think I still don't know enough is my answer.
Great, thanks, Nadia. That's a good perspective from what our machine learning researchers experience as you go through FDL. Maria, do you have any, since you kind of have, this is more of your domain, anything that's most surprising to you just throughout your whole career about lightning?
So I was surprised how little I knew about lightning despite being a thunderstorm researcher. So there is a lot to storms. So I really focus on those specific hazards of tornadoes and hail. And there's so many different components that are associated with storms. So yeah, one surprising thing that I learned, and together as a team, we learned about this, was a lightning jump signature. And I'm still working to understand that. So I'd be happy if any of our teammates could further explain this, but just learning that previous research has found that an increase in the lightning rate or the flash rate is detected prior to some of these severe hazards occurring is really interesting. So yeah, I've learned a lot.
Great, thanks. Do we have anyone else from the team that would like to share anything before we go through some other questions?
Yeah, I could add, there's one kind of record, world kind of record that was IATM published, I believe, a week ago or 2 weeks ago, that it was the kind of largest flash in the kind of world. So I believe it has over 1,000 clicks. I mean, it was, I think, in Brazil. So it is, I mean, it's a huge amount of the extent that the single lightning kind of cover. So I didn't think before I joined here that there could be such huge lightning events. So that for me, that was one of the kind of weirdest things that I have seen so far here. Yeah.
Great, thanks. And Marek, I think you had something to say as well.
Sure, I'll just add that one of the fun conversations we've been having with our mentors that they've had with everybody that's actually an expert on lightning is what is a lightning flash? It's actually a hard thing to define. Yeah, there's just differences between observing this from the ground and then from satellite, and how you take those observations and actually point out what's actually a flash. Where does it start? Where does it begin? Where does it end?
Great, thank you. And we have a couple more questions on here, and with this next one. So how many lightning strikes have we ever recorded to date using satellites? And this person suggested a guesstimate, millions, billions, more. So if you guys can't answer that, that's okay. You could even just talk a little bit about the size of the data sets that you guys are using today.
Yeah, maybe I could talk a bit about that. As we are using these GLM instruments, is records about 1,000 flash. No, is it 1 million? Sorry, 1 million flashes per day. So it has been working since 2018. So let's say if we are able to measure 1 million per day, you can only guess how kind of many of those are in the kind of whole planet, because GLM only sees the western kind of hemisphere. I mean, so we are still missing the other half of the world. Uh, so yes, if I had to do an estimation, it will be 2 million flashes per day that kind of happens here in Earth. So yes, that would be my estimate, but it is just a very not very solid guesstimate.
Great. Thanks for taking a stab at that one. So on another question, do we know what causes lightning? Maria or Marek, do you guys want to take that?
I'll let Maria take this one.
Thanks, Marek. My understanding is that so thunderstorms, as they are forming, they have very strong updrafts. So you know air going up, and as that occurs, there is grapple that forms. So it's like partially cooled or yeah, very highly cooled water that has parts of it that are solid. And there are charge separations that occur as this process is ongoing. And some of these differences in charge separations between the top of the cloud and lower down on the ground can help trigger these lightning events. However, that is if we're thinking about cloud to ground. And then there are also cloud to cloud events. There's something else called the sprite that I still don't know what that is, but it's on the top of the cloud. So again, there's a lot to lightning, and it's been fun to learn bits here and there, and also to hear about some of these fundamental questions that scientists ask about lightning, such as what is a lightning flash, like Marek said earlier. So yeah, it's been fun, and I hope that helped.
Great. Yeah. Thank you, Maria. And I think that the moral of the story is that lightning is very complex. And so I really appreciate you guys answering these questions. So I'll just go ahead.
Jump in and
Yeah,
say
go
one
for
more
it.
thing about that.
Yeah.
Just this won't necessarily help answer the question, but we sort of think about lightning as we see it on the ground. These strikes, and I think our mentors put it really well with what we're observing from this instrument from space. Lightning being like a light bulb, and since you have this cloud that is happening within this cloud that sort of acts as like a lamp shade. And so what we actually see from space is sort of what's coming through that lampshade from the lightning inside.
Great, thank you. So I think I'll go ahead and have one more question, and then we'll go ahead and wrap. So this audience member has asked, what is the rarest lightning that you've seen? So I know that you guys have talked a little bit about some of the anomalies that you have noticed in your work. I don't know if you guys want to talk about what you guys have seen from the data that you've looked at, or if there's a different event that you guys might have researched as part of this process.
Well, I'm no expert, but there are some bets called red sprites, I think that they are called. So they kind of happen up above in the atmosphere. So I'm no expert, so I think maybe all of my teammates can comment on that. But at least for me, that's one of the not common kind of manifestation of the kind of lightning. So yeah, that would be my.
I think the lightning around the equator is really fascinating because they seem to have more intense lightning events, especially like they have the Catatumbo lightning, lightning over the Amazons in Africa. I think it just inspires me when COVID is over to go travel to these places and see the lightning for myself.
I think it's also interesting, maybe just from our own personal experiences seeing lightning. So as you mentioned, Sarah, we live in Colorado and there are many storms and especially over the last month, there have been some very strong ones. And it's been interesting to see the different life stages of a storm. So early on, there might not be a lot of lightning, but sometimes as the storms are dying, there's a lot of cloud to cloud lightning occurring. So it seems there's patterns in the data, and hopefully machine learning will help us better understand these patterns.
Great, thank you. Marek?
I was just going to give a different answer, which is one incredibly cool thing I saw was just a video Maria had of being extremely close to a tornado. And that's not something I had seen before.
Yeah, so there's storm chasing, which we won't be doing, but maybe one day we can all go together.
Thanks, Maria. I think after being in Colorado and having a severe weather alert, but it didn't say tornado, and getting stuck on the side of the highway while a tornado touched down, I'll let you guys do the storm chasing. But I'm really excited about you guys' work during the summer and excited to see what you guys come up with, and just would like to thank you guys, and thanks to all of our viewers that have joined us today. We're really grateful that you guys are joining in, and we'll have another one later this week. So with that, thank you for joining the SETI Facebook Live.